Another day, another Maker Advent, and today we're just going back to day one with the Pi Maker Advent calendar. Lovely piece of kit. We've got a Pico H, we've got a breadboard, and we've got a very coiled micro USB cable. This board I've just flashed with the very latest MicroPython release. It's relatively easy. It's all explained on the Raspberry Pi website, and also there's a guide on tomshardware.com. Shameless plug. We're on to day 3 now, so we're doing day 2 of the Pi Maker Advent calendar. I know, slightly confusing, but we're mixing up the content. So here is day 2. I've got it out of the box already. Well, I've got it out of the big box. Let's open it up. I wonder if anyone got the Brad Pitt joke on day 1. Like, what's in the box? Also, this box is really tightly packed. I don't want to rip it. There we go. There we go. Right. Let's put it out. Put you over there. We have got 3 resistors, 3 wires. Was it 4 wires? 4 wires and 3 LEDs. Okay, let's have a look, see what we've got then. So I've snuck a peek already at day 2's instructions. It's as if I have a bit of planning to do for this sort of thing. And you get 3 LEDs. I think it's red, green and blue. Well, 3 different colours anyway. They're all clear, so that's first annoyance for me. I like, oh, come on, I love LEDs. I've got thousands of them. But clear LEDs, it means I've got to plug it in and see which colour they are. If they were pre-coloured, let me just go to my drawer here. There we go. If they're pre-coloured, that would have been better. But it's a minor annoyance, not an issue. LEDs are okay, so let's look at the resistors. I've got to take this off camera a second so I can get close enough to it with my eyes. At least 220 ohm, I think they're 220 ohm. And we've got 4 of the jumper wires. There we go, keep it in shot, Les. You were doing so well yesterday. So what I'm going to do is a jump cut to where I have this fully built and ready to go. So, jump cut. Okay. Partway through the build, so I've got 3 LEDs in. They're 330 ohm resistors, not 220. The red was an orange. My bad. So what I've done is I've connected the ground pin of each LED, the short leg, to the resistor, which is in the ground just down here, the channel. And I'm going to start wiring up the connections from the Pico H to the LED. So there's going to be 1 for ground, so 1 connection is going to go from the Pico into the ground rail. Then I'll have 3 GPIO pins connected to each of the LEDs. Anyway, jump cut. And seamless jump cut over. Right, we have all the wires connected. I haven't tested LEDs yet, saving that for the camera. We need the big surprise. Wiring's easy, no problems there at all. If you're a seasoned maker, this is bread and butter for you. If you're new to this, take your time. Every connection, just double check yourself to make sure it's okay. There's no time limit, it's not a race, just have a go and see what works for you. So what I'm going to do now is I'm going to go to Phony. So there's Phony, and you can see that this Pi is connected. There's no code on it whatsoever, it's just now a machine sat there waiting to be given an instruction. The instructions, handily, the Pi Hut have given us. So I'm going to just pop over to that page now and I'm going to highlight. Oh, there's a copy button there. I really should just double check that really, shouldn't I? I'm going to paste that into Phony. Okay, so I've got the code from the Pi Hut's website. And I've just pasted it straight into Phony. So, from machine import pins. So we're going to import a class from a library, a module that says, okay, work with the GPIO pins. This is how we do it. I'm going to import time, and time is used in many projects just to add delays. So if you want to make something blink on and off with a delay, you add a time and a sleep. And a sleep's just there to say, stop for a second, now do something. We've got 3 objects, pin 18, pin 19, pin 20. These objects are referring to GPIO pins. So red is on pin 18, so I believe. It's an output. Amber, so yellow amber is 19, it's an output. Green is on pin 20, and that's also an output. We then set the value of each LED to 1. In other words, on. Turn red on, turn amber on, turn green on. Wait 5 seconds, turn them all off. It's as simple, turn it on, see what's working, check, Done. So I'm going to run this code in Phony now. So I need to save it to the Pico. So can you see that? No, you can't. But I've got a little dialog that pops up that says Raspberry Pi Pico to save to. And I go yes. And I'm going to call it blink.py. And now I'm going to click on run, the green button. And you should see in the bottom right, the LEDs come on. Oh, red, amber, green. Okay. So I've got it green, amber, red in this case. So is that right? Is that pinout correct? Is 18, 19, 20 the right way around? Let's go to pico.pinout.xyz. Okay, so yeah, 18, 19, 20, you can see there. Bottom right, it goes 16, 17, ground, 18, 19, 20. So 18, 19, 20 we've got there. That seems right. So are they connected in the right way? So that was green. Now it should be red. So it should be red, amber, green. So I've got to swap these two around. Not a massive job. There we go. But then watch it not work because I've done it the wrong way around. That usually happens. One moment, I'm getting old and decrepit. My eyesight is failing me. So there we go. So yeah, this is where my little issue before of coloured LEDs would have been better to show which one's which. But not a massive issue. Yeah, so I'm going to check now that it's working. So I'm going to run the code again. We should see red, amber, green. Red, amber, green. Cool. So following day 2's instructions, we'll learn how to do blinking LEDs, which is important. If you can learn how to make an LED blink, then you can make a motor spin. You're turning a pin on and off, and via a motor controller, which handily I've got one here because I've been doing some work today. Wow, that's messy, that desk, Les. There you go. L298D, which is the breakout board from L298N. Yeah, if you can send a pin high or low, you can control one of these to connect to a motor and make things spin and move and make robots. And after that, you can do whatever you want because you've learned the basics. So, there we go. Day 2. We have blinky LEDs. Should we do something really quick to make it a bit more fun? Edit the code to make it just keep blinking and blinking and blinking. Just our own little thing. Okay, this is all off the cuff. I haven't rehearsed this. Let's do a for loop. For I in range, what? 100. We're going to just set the value of 1. Let it sleep for, if we do 105 seconds, it's going to be a long time. So let's do 0.1. Then we're going to set the values to 0. Then we'll do time.sleep 0.1. So you should see the LEDs blink really quick. So let's save this to the Pico. You can see that on the bottom right there. Yeah, you can. So let's make these things blink. Run. There we go. So that's 100 times. Nice. Easy. So that's it for today. We've made LEDs blink. We've learned a bit of electronics. We've done a bit of circuits. And we've done some MicroPython. That's it for now. See you later. Bonus content. So we used previously to turn the LEDs on and off. We says LEDs value of 1 for on and 0 for off, and had like a big section of code. But did you know you can also use toggle? So what toggle means is if something's on, it'll be turned off, and if something's off, it'll be turned on. And just by using those 3 commands, red.toggle, amber.toggle, green.toggle, and then a sleep of 0.1 seconds, we can reduce all of that code down into those lines, and away we go. The same thing happens. So let's just quickly turn that on, and let's swap to that camera. You can see they're blinking on and off. A little bit easier. Anyway, cheers.